Assalamu alaikum, dear students. Our today's topic is for class 12th, subject physics, and the topic is proof of Gauss's law. In the previous lecture, we have already discussed about the Gauss law. We know that this Gauss law is the relationship between the total electric flux passing through a closed surface and the net charge enclosed by the surface. And this Gauss law, it states that the total electric flux that passes through this closed surface, that's equal to 1 over epsilon times 1 over epsilon naught times the net charge enclosed by the surface. And this Gauss's law that's given by the total electric flux phi E. So phi E, so it's the electric flux phi E, it represents the electric flux that is equal to 1 divided by epsilon naught times the net charge enclosed by the surface. But we have already discussed this electric flux phi E, that is equal to closed integral of E dot ds. So closed integral of E dot ds. So we can write here this electric flux that is equal to, we can write in this way, closed integral of E dot ds that is equal to 1 divided by epsilon naught times the net charge enclosed by the surface. Or we can write in this way, closed integral of E dot ds that is equal to q divided by epsilon naught. तो ये हमें सॉल्व करना है, ये हमें डिराइव करना है, यही तो प्रूफ ऑफ गॉस लॉ है. So it was a statement of Gauss law, the total electric flux that passes through this closed surface, that passes through any closed surface, that's equal to 1 over epsilon naught times the net charge enclosed by the surface. तो आज हम derive करेंगे या इसका proof हम निकालेंगे आज. So our topic is proof of Gauss's law. Now, in order to derive Gauss's law, so we consider a point charge. Now the point charge is located at this point, at point O. So we consider a point charge plus Q. Now this point charge is located at this point, at point O. Now we'll draw a closed surface. तो Gauss law के लिए जरूरी है कि it should be a closed surface. It can be any surface. It can be a cylindrical surface, cubical surface, but the most convenient surface, that is a sphere. So we draw a sphere. So here we draw a sphere of radius r. तो radius r, तो radius इसका जो है that is r. Now we know that this point charge, it is at the center of the sphere. ये sphere के center में है, so that the electric field around the surface, that will be same in all directions, that will be equally in all directions. So the direction of electric field, or we can say here, this electric field, it's radially outwards. So it's the radial electric field. We can write it as E. So direction of electric field in this direction. Now, when we draw a sphere, see here we draw a sphere of radius r, so that it becomes a Gaussian surface. अब ये आपको मालूम होना चाहिए Gaussian surface क्या है. We know that Gaussian surface जो है, it's an imaginary surface. ये एक imaginary surface है. It has no real physical existence. तो यहाँ पर हमने क्या किया? We draw a sphere of radius r, so that it becomes a Gaussian surface. Now it's a closed surface. Now we choose a point, we choose a small area element. तो इससे पहले आपको ये मालूम होना चाहिए कि हमें यहाँ पर क्या निकालना है. हमें ये निकालना है कि अगर हमने यहाँ पर रखा है प्लस क्यू, पॉइंट चार्ज हमने यहाँ पर रखा है, जो इससे इलेक्ट्रिक फील्ड निकलेगा, जो इसका इलेक्ट्रिक फील्ड होगा, दैट द टोटल इलेक्ट्रिक फ्लक्स, जो यहाँ पर इलेक्ट्रिक फ्लक्स होगा, दैट पासेस थ्रू दिस क्लोज्ड सरफेस, that is equal to 1 over epsilon naught times the net charge enclosed by the surface. जो आपके सामने इस वक्त है, the total electric flux phi, that is equal to 1 over epsilon naught times the net charge enclosed by the surface. तो इसके लिए हम क्या करेंगे? तो हमने ऑलरेडी यहाँ पर Gaussian surface बनाई है यहाँ पर, तो आप देख रहे हैं कि Gaussian surface है. So we choose a small elementary area. So here we choose a small elementary area ds. तो इसका नाम हम यहाँ पर रखेंगे ds. ये जो small elementary area, it should be as small as possible, such as a point area. So we can write it as, और आपको ये भी मालूम होगा कि the direction of this area element, जैसे अगर हमारे पास ये area element है, so the direction of this area element, that's always perpendicular to the surface. So अगर यहाँ पर area element हम ले रहे हैं, तो direction of the area element that should be along this. So this will be the direction of this area element. ये area element. तो आप देख रहे हैं यहाँ पर the direction of electric field, जैसे electric field की direction आप देख रहे हैं, or the direction of area element that is same. So that means इनके दरमियान जो एंगल आ रहा है that is 0 डिग्री. तो उससे पहले आपको मालूम होना चाहिए कि उससे पहले आपको ये मालूम होना चाहिए कि ये जो इलेक्ट्रिक फील्ड है, द इलेक्ट्रिक फील्ड एट एनी पॉइंट ऑन दिस सरफेस, ये तो हमने ऑलरेडी निकाला है. तो दैट इलेक्ट्रिक फील्ड ई, इलेक्ट्रिक फील्ड एट एनी पॉइंट ऑन दिस सरफेस दैट इज इक्वल टू, ये तो हमने ऑलरेडी डिस्कस किया है. सो इलेक्ट्रिक फील्ड एट एनी पॉइंट दैट इज इक्वल टू 1 डिवाइड बाय 4 पाई एप्सिलॉन नॉट क्यू डिवाइड बाय आर स्क्वायर. ये तो हमने ऑलरेडी डिस्कस किया है और हमने डिराइव भी किया है ये. तो ये हम यहां पर इस्तेमाल करेंगे. तो हमने यहां पर क्या किया, वो जो है स्मॉल एलिमेंट्री एरिया, तो हमने यहां पर एक एलिमेंट्री एरिया लिया है यहां पर, ठीक है. हैविंग एरिया आपने उसका लिया है दैट इज ds. नो द एंगल बिटवीन, आप देख रहे हैं यहां पर कि डायरेक्शन ऑफ इलेक्ट्रिक फील्ड, क्योंकि आपको मालूम है कि दिस इलेक्ट्रिक फील्ड इट्स रेडियली आउटवर्ड. सो यहां पर इलेक्ट्रिक फील्ड इस डायरेक्शन में होगा, यहां पर इलेक्ट्रिक फील्ड इस डायरेक्शन में होगा, ठीक. तो यहां पर अगर आप देखेंगे इलेक्ट्रिक फील्ड विल बी हियर एंड द इलेक्ट्रिक फील्ड विल बी सेम ऑन द गॉसियन सरफेस एट एनी पॉइंट ऑन द गॉसियन सरफेस. हर पॉइंट पर अगर आप देखेंगे, यहां पर अगर आप देखेंगे इलेक्ट्रिक फील्ड क्या होगा, वो सेम होगा, क्योंकि दिस पॉइंट चार्ज इट्स एट द सेंटर ऑफ द स्फीयर. So this is at the center of the sphere. So here angle between, आप देख रहे हैं यहां पर angle between E, that means the electric field, जो electric field यहां से निकल रहा है from the point charge and और ds जो small area element हमने लिया है that is equal to 0. वो 0 है, आप देख रहे हैं यहां पर that is 0 degree. But according to Gauss law, so Gauss law states that, or you can say according to electric flux जो यहाँ पर कह रहा है, जो यहाँ पर electric flux निकल रहा है, that is, we know that this electric flux, we know that phi e, that is the electric flux, that is equal to closed integral of E dot ds, closed integral of E dot ds. आप यहां पर कहेंगे कि क्लोज इंटीग्रल क्यों ले रहे हैं, तो हमने यहां पर एक एरिया एलिमेंट लिया है. तो ठीक है, हमने एक एरिया एलिमेंट लिया है, तो यहां पर जो दूसरा एलिमेंट होगा, फिर तीसरा एलिमेंट होगा, इस तरह चौथा एलिमेंट होगा. सो ऑल द एलिमेंट्स व्हिच फॉर्म्स द क्लोज्ड सरफेस, व्हिच फॉर्म्स द स्फीयर. तो इसलिए हम यहां पर ले रहे हैं क्लोज्ड इंटीग्रल ऑफ E डॉट ds. अब जितने भी एलिमेंट्स इसमें आ रहे हैं, स्मॉल एरिया एलिमेंट जो क्लोज सरफेस को बना रहे हैं, तो उनका सम आप यहां पर लेंगे. उसके लिए हम यहां पर ले रहे हैं इंटीग्रल और फिर क्लोज्ड ले रहे हैं, क्योंकि इट्स ए क्लोज्ड सरफेस. सो वी कैन राइट इट एज, so it's a dot product between the two vectors, so that is equal to closed integral of, so dot product between the two vectors, we know that dot product between the two vectors, that is the product of the magnitude of the two vectors and cosine of the smallest angle between them. So we'll write here ds cos of theta. So here theta that is equal to 0 degree. आप देख रहे हैं यहाँ पर कि इनके डायरेक्शन ऑफ इलेक्ट्रिक फील्ड एंड द सरफेस एरिया एलिमेंट, जो हमने एरिया एलिमेंट लिया है यहाँ पर, उनके दरमियान जो एंगल है दैट इज 0 डिग्री. सो वी कैन राइट हियर phi e is equal to phi e that is equal to closed integral of ds cos of theta. So theta is 0 degree, and we know that from the trigonometric table, ratio table, so cos of 0 degree that is equal to 1. Then we can write here phi e is equal to closed integral of ds cos of 0 degree, so that is 1. So we'll write it as 1. Or so this phi e that is equal to closed integral of E ds, closed integral of E ds. Now we know that the magnitude of electric field at any point on the closed surface that is same, so it is constant, so we can take it out. So phi e is equal to E closed integral of ds, closed integral of ds. or we can write here phi E is equal to, so close electric field E, closed integral of ds. But this closed integral of ds, that is equal to, so this it's the closed integral of ds, that means it forms a sphere. So the surface area of the sphere that is equal to 4 pi r square. 4 pi r square. Then we can write here phi E is equal to E, that's the electric field, into 4 pi r square. 4 pi r square. Okay. But we already know that this electric field E, phi E, is equal to, so it is equal to 1 divided by 4 pi epsilon naught q divided by r square into this 4 pi r square, 4 pi r square. So 4 pi r square and r square will cancel out. So we can write phi E is equal to 1 divided by epsilon naught times the net charge enclosed by the surface. So this is the proof of Gauss's law. This is the proof of Gauss's law, and it states that the total electric flux that passes through the closed surface is equal to 1 over epsilon naught times the net charge enclosed by the surface. तो अब यहां पर आप देख रहे हैं कि इट वाज अ सिंगल पॉइंट चार्ज इनसाइड द सरफेस इफ देयर आर नंबर ऑफ चार्ज इनसाइड द सरफेस. तो उस पर बात करते हैं. So this is Gauss law. This is Gauss law. ये Gauss law. Now, if there are number of charges inside the surface, if there are number of charges inside, there are number of charges inside the closed, means Gaussian surface, then the total electric flux phi E, that is equal to phi 1, or we can write it as phi E1 plus phi 2, means phi E2 plus phi E3 plus dash. So there are number of charges which are present inside the surface. The total electric flux, all the charge, जितने भी charge इसमें surface में होंगे, they will contribute the electric flux. The total electric flux through this total electric flux that passes through this closed surface, due to all other charges, due to all the charges which are inside the surface, that will be equal to the algebraic sum of all the electric flux which are inside the surface. Then we can write here. So here आप यहाँ पर लिखेंगे phi E n. Then we can write here phi E is equal to phi E1. So it will be equal to, according to this, so it will be Q1 divided by epsilon naught plus, so phi E2, it will be Q2 divided by epsilon naught plus Q3 divided by epsilon naught plus dash plus Qn divided by epsilon naught or we can write here phi E is equal to 1 over epsilon naught, so it's common. We can write here Q1 plus Q2 plus Q3 plus dash, it is Qn. So here this Q1 plus Q2 plus Q3 dash. So I can write in this way, phi E is equal to 1 over epsilon naught times Q. So this Q is equal. So this is also the Gauss's law, but this Q we can write in this way. This Q is equal to Q, that's equal to summation of I starts from 1 to n Qi. So here when I is equal to 1, so it will be Q1, is तरह Q2, Q3, Q4 dash. So this is the proof of Gauss's law with the number of point charges which are inside the closed surface.